Hello, my name is Claudio Tag, and I am the chief architect for what we call automation software across Asia Pacific, which includes integration as well as API management. And today I want to share some of the lessons that I've learned traveling across Asia Pacific and seeing customer implementing API management solutions, whether with IBM software or with competitor software, and what made them successful. What are the lessons that they've learned throughout that journey? And I want to start from a definition that Gartner gave a couple of years ago now around treating APIs as product. Even if you don't intend to charge for the data in those APIs, even if you don't intend to monetize those products, APIs are essentially the way for you to convey data outside of your business and for your consumers to access that data that is important to them. And therefore, you need to provide that capability as if you were giving them a product that they pay for. So, what are those lessons that we are learning? What are the things that you've got to do well as an organization to be successful at providing APIs out as products? We start from development and making it easier for anyone within the organization to create new APIs in a high quality form so that you know that what's provided out to your consumers follows a certain level of standard. Then we talk about governance and how it is important for those API to be lifecycle managed, to be versioned, to be provided in a way that is consumable. And we talk about testing and how we can, with the plethora of new APIs being developed, automate the testing of those APIs inside a CI/CD pipeline. And we talk about observability, and I'm choosing the terminology carefully here. It's not only API analytics, how our APIs are consumed, that I'm talking about. It's not only monitoring what happens when something goes wrong in my API transactions, but observability, a full end-to-end visibility of why things might have gone wrong in the way that APIs are consumed. And finally, security, which is a topic in its own right in these days, and how security for APIs is evolving as they are becoming one of the widest attack surfaces across our organizations. And all of this with machine learning and artificial intelligence coming to change the way that IT in general, but also API development and API management is done. Sometimes to make it easier, and sometimes to make it more efficient as well. So that is across the board in the 5 tenets. Okay, let's start from the beginning. Let's start from API development. So first of all, when we think about API development, we think about the people, the personas that develop those APIs. And we start from what traditionally were the personas working with APIs, your integration experts, maybe coming from an SOA or ESB background that create reusable services exposed across the organizations, to full stack developers that create applications which expose APIs out to be invoked or to be provided data with. And as we move towards microservices architectures, as we adopt cloud native principles, the various components, even within a single application, start communicating with each other through APIs. So cloud native developers are now great producers of APIs. On the other end of the spectrum, though, we want to empower people that maybe don't come from that IT background, but need to create connectivity between different applications or software as a service componentry using things like API. Those are our new integrators, our business technologists, our citizen developers that need low-code, no-code environments to be able to create those services and those APIs. If you look at it from an historical perspective, even before we start adding things like machine learning and AI, my SMEs, my full stack developers, were using APIs to tackle problems that had a high complexity and potentially were costly to solve. And they use powerful tooling to go and tackle those issues. And on the other end of the spectrum, my business technologists my citizen developers, they would probably use low-code, no-code tooling to tackle tactical issues like connecting an Excel spreadsheet with Salesforce software as a service implementation in order to use technology to make the day-to-day life easier, which leaves a big chasm, a big gap in this long tail of APIs from the very complex one to the very easy ones. Now, this is where bringing in things like machine learning helps reducing that barrier of complexity, helps making it easier for both my citizen developers and my enterprise integration people to go and create APIs without having to spend a lot of time creating security policies or mapping data or converting protocols. It's machine learning that makes some of that stuff more achievable in a shorter time span, covering more of this spectrum. When we add support for declarative notations, for direct integration with CI/CD pipelines, for open source languages and frameworks, then our cloud native developers can start expanding the reach of that API creation. And again, when we bring in new forms of AI that are more generative in nature, that are able, like large language models, to create new content based on prompts, then both the right-hand side of the spectrum of people and personas and the left-hand side become more productive because we further reduce that complexity and allowed all of our persona population to cover the entire spectrum of the API use cases that we've got here. And that is true not only across those different personas, but also different technologies. Whilst we matured the ability of creating APIs using REST and SOAP, asynchronous integration protocols and patterns, it's now a portfolio, it's now a landscape of much wider set of protocols and interaction patterns that we're looking at, from GraphQL in the synchronous space to events and Kafka in the asynchronous space, that we need to be able to empower developers and API developers to create and API operators to manage. So let's say we do that. What are the two things that people really care about today that they couldn't do maybe last year? From what we're seeing in the market, there are two main different technologies that people want to be able to create APIs in. One is GraphQL. GraphQL is gaining vast amount of popularity because of its capability to more easily create new endpoints that expose data. For the ones of you that are not familiar with GraphQL, GraphQL is a synchronous way of invoking HTTP endpoints, but differently from REST, GraphQL calls don't retrieve the entire representation of a resource, but can be used to query data at the back end. It's a query language that you put on that HTTP endpoint in order to retrieve exactly the amount of data that you need and the data fields that you've asked for. So you can be very fine-grained in your request and very efficient in the retrieval of the data you need for your application development. And at the same time, it's powerful for API developers because you expose one endpoint that now covers a myriad of different use cases without you having to create different representations of different resources for all of those use cases. And on the other side of this slide, we're talking about Async API. Async API is a project that describes, similarly to what the OpenAPI specification does for synchronous invocations, asynchronous ones. It's about consumer understanding of how you can access, subscribe to a set of asynchronous events. And it would be great to have tooling that can interpret async API specification in the same way we interpret OpenAPI specification, because that now gives us access to subscribing and consuming things like Kafka events, messages coming from technologies like MQ or Solus or you name it. So two very exciting areas of expansion for our API development. Second tenet is API governance. API governance is a fundamental part of API management. Without being able to govern your APIs, as we made it easier now to develop a lot of those, you end up with sprawl. You end up with confusion across the different APIs that have been created by your different teams. And we said it at the beginning that Gartner mentioned that we should treat APIs as products. And what does that mean in practice? It means being able to package those products for consumption, publish them to a portal or a catalog where external consumer can browse them and select the product that they want to consume, and giving different versions that we govern of those different products. Similarly to a phone, I buy a phone 2 years from now. I want to be able for my existing phone to work until then. I don't want to be forced to adopt the latest version every time one comes out. And finally, analytics of behavioral patterns when it comes to consumption of our products. Are these products popular? Do I need to make changes to these products for wider adoption? All of that is part of that governance life cycle that is a key element of API management. And that is true not only for creation, testing, and publishing, which is very much focused on the provider side of API creation, but also for discovery, consumption, monitoring, and feedback, which is the consumer focus of that API lifecycle. In an iterative process that makes sure that every time an API is created, it can be made better, or an API product, it can be made better the next time around. We've learned how to do this very well with REST and SOAP. We can do things now like automated linting, which is the ability of defining rules and rule sets coming from specifications like the OpenAPI specification or OWASP, or my custom rule sets for my industry or for my organization, and automatically validate them against my API catalog even before we publish those APIs, so that we know that we're going to put out APIs that are solid, that are secure, and that follow our internal and industry standards. So we've learned how to do that, but we want to expand all of the same capabilities across the entire life cycle, across the automated governance capabilities beyond REST and SOAP, with GraphQL or with Kafka, with async API, as I mentioned. So the key, the fundamental winner of an API management toolset is the toolset that allows you for that API governance to be automated and easily implemented, but also to be used across a variety of different formats, a variety of different protocols, a variety of different interaction patterns, so that I can treat my APIs, now intended as a generic term, my exposed services, in a very consistent fashion, independently from how the data is consumed or for the protocol that has been chosen for that API to be exposed. Number 3 is testing. The importance of testing and automated testing is undoubted. There is a number of reasons why testing is becoming more important. First of all, because, as we said a number of times now, there are more APIs out there, which means that manual approaches to testing don't cut it anymore. It's impossible to test all of those APIs out in a manual way, from creating a mock whilst I develop my APIs to develop it in a test-driven development approach to test it once the API is ready. We need to use automation. But the second aspect of why testing has become so important is how our consumers' behavior. It's not acceptable anymore to our API consumers to receive an error, even if that error says, I'll try again or come back later. That's got a direct impact on the reputation of the API provider, and sometimes a financial impact, because consuming applications rely on those APIs to always be working. So it's not acceptable not to have fully tested your APIs before pushing them out. So what is a solid strategy to testing? This is where AI and machine learning once again come and help us with this vast amount of APIs that we're producing. Obviously, automation is key. I need to be able to automate the way that tests are performed against my APIs. But machine learning models can help me doing that across the life cycle of that API itself. From using bias random models that help me create tests whilst I'm developing the APIs by simply creating a set of random invocations of that API whilst I develop it in a very test-driven development approach, to using things like natural language processing to interpret the OpenAPI specification, and based on what's in that spec, creating a set of test assertions that can be performed against the API itself. Things like I can see 4 operations, I can see this number of paths, and the payload needs to be in this certain shape, and the return code needs to be 200, and I need to have a response that contains this type of data. All of that stuff can easily be inferred using the OpenAPI spec and can be automated as a set of test assertions that are part of your CI/CD pipelines when you push your APIs from test to the next staging environment. And finally, once those APIs are in production, we should have the ability to take real consumption data and use things like generative AI to expand from that existing data and create a data set that is much wider and has got the ability to cover every functional and non-functional scenario for those APIs. So it's quite exciting to see how different forms of AI come to help in that testing lifecycle. Observability. And I said it before, observability is different from simple API analytics, which is obviously important but not enough, and from monitoring. And that's because it's very hard to go and fix something that we don't have full visibility of. And whilst API monitoring has been helping us for quite some time now, observability is much more than that. Monitoring focuses on telling you what went wrong. Observability gives you a number of additional tooling or capabilities to tell you why that thing has gone wrong. So it's really focused in automating and aiding what we call root cause analysis, so that whenever there is an issue, it's very easy for you to identify it and solve it in a lower time, mean time to resolution. What are the various components that make that root cause analysis easier? Well, there is a variety of them. One that is particularly important in API transaction is tracing. And for that tracing to be able to go across different components, not only the API proxy, and to be a set of data that is provided in a way that is as low touch as possible without having to go through a massive amount of instrumentation of your systems, so that you can start from a REST invocation of your API and trace down each of the steps of where that API transaction gets executed, from what's happening in the gateway or what's downstream from the gateway, in this case, an integration service running in an integration engine that goes and puts a message in a queue manager. And for each of those steps, look at the code that gets executed in that different runtime that is part of that transaction, so that if there is an issue, you can identify the single line of code that is the cause of that issue, making that root cause analysis much, much faster to achieve. And finally, security. Security, again, is an enormous topic that we won't be able to do justice to in just a few minutes. But it's true that API security has become an integral part of IT security concerns today. Just in the past 12 months or so, more than 80% of a security officer reported API security incidents. And across all cloud incidents, 2/3 are to be attributed to APIs and to wrong configuration of APIs. And it's not only Gartner that says it, but a number of different analysts and industry players out there are convinced that APIs will be the most widely adopted attack surface or attack vector for IT security incidents or IT security threats. So as we create so many more of these APIs, it's harder for us to secure them. It's harder for us to control what they're doing, and then it's much easier for malicious players to leverage them for what those APIs were not intended to do. And the advent of generative AI is only making things worse, because that's although it's something we can use for testing and for development, it's also a massive aid to hackers that can use this new vast amount of data to make their threats more sophisticated. Why traditional security when it comes to API is not enough anymore? Well, we're very good at traditional security, first of all. We're great at doing things like penetration testing, having gateways that are immensely secure, preventing things like denial of service attacks, creating policies that we can enforce in a very fine-grained way to stop attackers. But what's happening is also that with the advent of microservices, the perimeter of our applications are blurring, and we're using APIs internally to our applications for any source of communication. And if something happens, like those APIs get wrongly put on the outside network, or there is a different network configuration that makes them pop out outside of the organization, or simply if I have a potentially malicious attacker within the organizations, then all of these new APIs are a potential attack vector. And sometimes we don't even see what those APIs are unless we explicitly tell people to go and put on a massive thousands of entries spreadsheet all of the new APIs that are creating. And we cannot adapt dynamically to potentially malicious attacker trying to leverage those APIs. So advanced API security is about a number of things. First of all, it's about visibility. It's about discovering all the APIs across your estate. And this is not static service discovery in which you register a service into a catalog. This is about dynamic discovery of new APIs that are laying around your network and that we can find out about. It's about assessing the security posture of those APIs against internal rules or external rules like OWASP to give you a view of how exposed you are to potential malicious attacks. And finally, it's about understanding consumers' behavior in order to identify attacks as they occur and to create remediations to those attacks in as fine-grained manner as possible, to the point of maybe stopping one potential attacker due to their behavior by using their IP or their token, without having to take down the entire API or shut off the entire gateway. So those three things are the key tenets of API security. And that's across the lifecycle. It's not only about how we develop and manage our APIs, but it's very much about using information around that behavior to secure single endpoints against single attackers. All right, in IBM, we're very excited about all of this because across our API-led integration portfolio, which is made up by IBM App Connect and IBM API Connect, we are able to tackle a lot of those tenets and what's behind those tenets in a way that is pretty enterprise-wide. From being able to use low-code, no-code, and machine learning-aided tools to create APIs, to govern them across the life cycle in a way that is as automated as possible, to have testing that is augmented by machine learning and AI that you can embed in your CI/CD pipelines, to use IT observability tools for API observabilities and aid root cause analysis when an API incident occurs, to do API advanced security together with static API security at the gateway level and dynamic API security for discovery, posture management, and behavioral analysis of consumption. API Connect is our lifecycle management product that has been there for quite a while and is extremely successful at what it does. But we've augmented its capabilities with a partnership, a global partnership with a company called No Name Security, which is all about dynamic advanced API security. And we've recently acquired a company called StepZen, which is all about declarative creation of GraphQL APIs that then get managed by our API gateway. And we're pretty proud about the work that we're doing. We've been in all the Leaders Magic Quadrant by different analysts for the past 7 years as the top right representatives, the leaders. But we also like to think about API management as not only a set of features and functions, but very much about a set of tools to implement real life use cases. And that's where we shine at. It's not really only how many things we can do, but how easily can we help customers implement a multi-experience architecture or integration using their APIs or doing things like open banking, open retail, you name it. It's about what you do with those features and functions. Well, if you're interested about knowing more, there is much more that we've learned across the conversations with customers in Asia Pacific and around the world. There's much more that we're doing in the toolset and in our strategy to facilitate reaching success when it comes to API management. So reach out to us, come and talk to us. We'll be happy to take this conversation further. Thank you very much.